Okay, so another one for us to take a look at. This one's a little bit different. It deals with some of the material that we covered later in class, which is impulse. So in this one, the problem says an 11-gram bullet is stopped in a block of wood. The mass of the wood is 4.6 kilograms. The speed of the bullet plus wood combination immediately after the collision is 0.37 meters per second. Oh, I apologize. This isn't actually impulse at all. This one's actually just momentum. This one is going to be, we've got a block, and we're going to take a bullet and fire it into the block. This is for educational purposes, so that qualifies under fair use, I think. Anyway, the bullet is going to go into the block. They tell us that the mass of the block, mass of the, I'm going to say W, I think that's what they give us for wood, because otherwise bullet and block both read. So, 4.6 kilograms. In regards to the thing that I mentioned before with impulse, you'll see that in one of the other videos and homework questions. But we've got the mass of the wood is 4.6, and the mass of the bullet is 11 grams. Once again, 11 grams is 0.011 kilograms. We want, whenever we're doing math, we want to convert it to SI, because you put SI in, you'll get SI back out. If you leave it as 11, if it's 11 kilograms, that means A, the bullet is like 25 pounds, which is a little ridiculous, and 2, it would be much more massive than the block of wood, which also doesn't make much sense. So, pay close attention to units on this one. Okay, what they're describing is the bullet embeds itself in the block, and when they are stuck together, you might look at this as the final for both of them together is 0.37 meters per second. What they're asking is, at some point before this, the bullet hadn't hit the block yet. And what they'd like to know is, what's the initial velocity of the bullet? Now, one other thing that we're going to need to know is the initial velocity of the wood, but we've got a block of wood, presumably, it was just sitting there, minding its own business. 0 meters per second. As a side note, this is something that, well, similar to things that they do when actually doing ballistics tests. So, this is not an uncommon thing. This is actually a real-world problem. Okay, they asked what the original speed of the bullet was. All right, well, in this case, I'm going to set up a system. We've got the bullet flying through the air, and we're going to ignore anything like friction. Let's say that we're on a really smooth table here, because we're going to find right after they collide that the block and bullet combo are going 0.37 meters per second. Friction could kick in and bring it to sliding to a stop. There are other things that we could look at, but right after the collision, it's going this fast, and we have no significant external forces right before and right after the collision. So our momentum should, for the most part, be conserved. So what we're going to do is, this is a circumstance where the initial momentum will be equal to the final momentum, but I didn't give you, or we didn't give you information about the initial, we gave you information about the final, so that means that we've got the final is the bullet block combo, so it will actually be the mass of the bullet plus the mass of the wood times the final velocity. Well, in this case, we've got 0.011 kilograms plus 4.6 kilograms times the final velocity of the whole thing, which is 0.37 meters per second. We can now go through and find what the total momentum after the collision was. Plus 4.6 times 0.37. If I've done this correctly, I find that my total final momentum is 1.7061. There's some extra numbers on there, but I refuse to go above 4 significant figures. Kilogram meter per second. I could probably call this 1.71 and it would be totally fine. That's going to be equal to the mass of the bullet times the initial velocity of the bullet plus the mass of the wood times the initial velocity of the wood. Now, We don't know the initial velocity of the bullet. That's what we're looking for. So that's going to be 0.011 kilogram times the initial velocity of the bullet, plus, I'm just going to fill in the takeaway on this. We have the mass of the block, 4.6, but we know that the initial velocity of the block is 0, so it has no momentum for us. So we have 0.011 V final, or I'm sorry, V initial of the bullet is going to be equal to 1.706 kilogram meter per second. I divide both sides by 0.011. I end up with approximately 155 meters per second equals the initial velocity of the bullet. 155, yep, 155.1. All right.